So we're going to talk about two things today. We're going to talk about sand, and to get into it, we're going to talk a little bit about soils, because sand is an important part of soil, and we'll go from there. Now, I start out with this, I don't know whether it's a funny cartoon or not, but it's one that I use, I used to use in the classroom when I was taking students down to the beach, because it turns out that we don't all share the same experiences, as this poor fellow seems to show. Never been to a beach before, doesn't quite know what to do. And I'm reminded, having taken students, elementary school students, to the beaches and so on, and there was one young lady that came down there one day, and she picked up this rock and she said, "Does anybody own this rock? Can I have it?" So the sort of universal background that we like to think we have probably isn't as universal as it used to be. But in any case, one of the things we usually did at the Urban Ecology Center with the classes was a little bit of soil sampling. And soil there's actually Wisconsin state standards, science standards for elementary school do in fact have a soils unit they're supposed to be doing. So it's always a good time we take students down to the Urban Ecology Center and collect some soils and see how they differ. Well, this one is one of the sites right at the top, past the bike path. You get up in the top, and there's a walkway there, and we have them take samples somewhere along the edge there. And these are a little soil sampler. You just sort of push it into the ground. It's got a little bit of teeth on the end. And at this location, we end up getting maybe 3-4 inches of soil if we're lucky. All right. And the question would be, I mean, this is probably typical for most of us in our own backyards, that if you dig down very far, you might get 6 inches before you start hitting the glacial till, which is the clay kind of stuff and so on. And so just to get some idea of variations in soils, we start here, we punch these in, take a look at them, see what we can see. And then if we go down to the river, that's a very different experience. We get down to the river, we get, these things are about 1 foot long, so we get about half a tube worth of sediments, and the part of it up here is predominantly sand. There's some soils down here, some organic materials and so on. And so it's quite different. And if we actually put a soil auger into it, you go down quite a ways, you can rotate this thing and push it down 2-3 feet almost. And when you pull it out, you've got predominantly sand. And so in a very short space of from the top to the bottom, we see quite a difference in the types of soils. And you might say that, you know, the stuff at the top, how long has it been to develop 6 inches worth? Well, my guess is the park was developed a little bit more than 100 years ago. And so probably like our backyards, all of the loose stuff that we have has only been around for a century at the most. We probably have no native soils. But if you go down to the riverbank, you can readily get, you know, 1.5 foot of recent material, which is not surprising because it's the overflow from the river when it floods. All right. So in a short distance, we see some very differences in the soils. All right. Let's just start with a few discussions of what soil is. And the first one, it just, you know, it refers to the loose top layer of the earth, as distinguished from rock, or I say in southeastern Wisconsin, it's glacial till. So it's got to be something that's not solid material and it supports vegetation. And another idea is this material is composed of 5 ingredients: minerals, organic matter, living organisms, gas, and water. And so this sort of makes sense too for most of you that do any gardening. You're very much aware that there's soil material, which is the mineral stuff, and there's certainly organic material, and there's also critters living in there. And if you don't have a little bit of air and water, you don't get much going on there. So that's all part of it. But I'm only going to talk about the mineral content. All right. Soil texture really relates to grain size of the mineral material. All right. And the 3 grain sizes of great importance to soils are sand, silt, and clay. All right. And you can actually distinguish the three of these. Sand is really, your eye is pretty good. It can see down to at least 2 millimeters. So if you can see the stuff, it's probably sand. Gets below that, and now you've got to decide what other things is it going to be. Well, silt is something that you can feel with your teeth. It's gritty. So occasionally you might see a soil scientist sitting down and putting a little bit of soil in his mouth and running it between his teeth to see what's there. And clay is really too small to see or feel. However, if a soil has lots of clay, one can roll clay worms. And so if the soil has only silt and sand, the worms will fall apart. If it's mostly clay, they will get nice long worms that you can grow just like kids do when they play with clay. Right? And I think that, the other thing you can do if you're trying to get some idea of your own soils, if you take a cup of soil and put it in a fruit jar and fill it with water and then shake it all up and let it settle out, you will find that the sand settles first, the silt next, and the clays on top of that. And it may take the clays days to settle out. If you've ever gone by Lake Michigan after a big storm, at least here in Milwaukee area, you'll see that the water is really murky out there. And if you watch it for a few days, you'll see it takes a couple of days for that to settle out. Well, that's the clay component that we're seeing. Okay? All right. In terms of where does sand come into soils? Well, they basically name soils based upon the composition of clay, silt, and sand. So if something is, the one we sort of would like to have, one of the favorite one is what we call loam. And it's one that has something like, let's see, I can always, something like about 40% clay or sand, about probably 20% clay, and then about another, gotta come back over here, probably another 40% silt. So all these add up and come up with different compositions. But soils will have quite a variety of compositions, and they all hold pretty well to their, you can grow a lot of things in a lot of variations, right? And this is just one that I used from class, just showing some of the soils around that I've worked with. Marquette, Michigan tends to be primarily sandy. Sun Prairie tends to be pretty sandy. Munising, Michigan tends to be a little bit on the clay loam sand side. Is not too bad. Milwaukee, we've got one over here, which is a sandy clay loam. I don't know where that one came from. It certainly wasn't my yard, because my yard is, once I get past the surface, it's all clays. So in any case, all right. Not to belabor the points about soils, but soils are strongly climate and location dependent. You can get a sense here that certainly the Southeast has very different soils than the Midwest and the north parts of the country. And that's, as Tim will probably tell you next class or meeting, is that soils are strongly dependent on a variety of factors, one of which is climate, which involves obviously rainfall, and the other part depends upon vegetation. If we just go to Wisconsin, the dominant types are, and this is another one of those things that if there's a way to name something, scientists will do it. And so when we look at soils, we can see there's a whole series of soils. And in Wisconsin, we've got two dominant ones. One we call alpha soils, and then to the north, we've got the ones which are spotted soils. If you go around Wisconsin much, this is the area where you get mostly the pine trees, the spruces, the balsams, and so on. Tends to be very acidic soils. The rest of the state tends to be fairly uniform kind of material, a good agricultural soil. All right. So, and then just to finish it off, every state's got to have a state soil. And in Wisconsin, it happens to be the Indigo silt loam. Up near, here's the location that you can see. And it's in one of the more productive parts of the state for agriculture. A lot of big productions of corn, beans, a variety of other things that grow there. But I will pass on that. I want other things. All right. So if you've done any gardening, you know very much that Sand and clay is important for water holding properties. And this is when we talk about these composition, we're talking about the texture. And certainly very sandy soils drain very fast, take nutrients, pesticides with the water as it sinks deeper. And central Wisconsin is of this type. It's a very sandy soil. We'll talk a little bit more about that later. Very clay-rich soils don't drain well at all. Keeps the soils very wet and often will drown the plants if you don't get enough air into it, enough circulation around it. And the amount of sand and clay is obviously related to the geology. All right. So, what we've just said is that sand is certainly an important component of soils, and it's the other thing is that not all sand is the same. Okay, and I'm going to mention that Wisconsin has some amazing sands. We'll talk about those in a little bit, and also some of those sands are shipped worldwide. All right. So first of all, where does sand come from? All right. Well, if you take typical types of rocks that we have in Wisconsin, these happen to be two of the granites. This happens to be Wisconsin red granite from probably the Wausau area. This is another one in the area. All right. And what happens if you put that into the atmosphere, you put it into the soils, you bury it, you have rain go on it and so on, all these little specks will disintegrate. There are some clear ones, there are some red ones, there's some black ones and so on. In the weather, those things disintegrate. And sometimes, as some of you may have had this experience in your own backyard, if you dig up at a boulder that might have been around, you find the thing begins to look sort of like this. It's breaking up, it's breaking down into pieces. And what's happening is that these igneous rocks are made up of a lot of minerals: feldspars, hornblends, amphiboles. These are all silica type minerals, and quartz. Well, most of those minerals over time will interact with water and weak acids and disintegrate. And what they break down into is they chemically change, most of those minerals chemically change into clay. Give it enough time, it will disintegrate, rearrange, turn into a clay. The only one that doesn't is quartz. And as I mentioned over here, quartz is very resistant to weathering, both chemical and physical. It's with us always, like death and taxes. Most other minerals break down except for quartz, right? So if we start looking at sands, this happens to be a sand from Doctor's Park, and you begin to see, well, there's some nice clear ones in here. That's probably almost all quartz. They tend to be angular. We see some darker ones here. These are probably some feldspars or some amphiboles, some breaking ones, but this is very typical. And what we're going to say is that when we look at sands, the shapes and their composition tell us a lot about the environment that they were formed. So we can take a look at this one, and if we go on and look at one from Cape Cod, it has some very great similarities to it. Again, it's very angular. There's some very clear species to it. Very angular, and just out of sort of interest, this type of sand, either Cape Cod or Wisconsin sand like this, when it gets angular, they sometimes refer to this as river run sand, or in this case, some beach sands. But these are very important for construction, particularly concrete, because they really like to have sand that's very angular because it binds better with the background cement material, makes a very tight bond. It's a little bit coarser grained than some of the other sands that we have. And so it's very important. And I might mention, of course, Wisconsin is a great source for sand, mostly because of the glacial background to the state. All the sands that were washed in at the end of the glacial period, so they're great sand deposits. It's hard to go almost anywhere without seeing a sand quarry up in West Bend area, down towards Beloit. Any of these places, you can see these great sand deposits. And so, relatively speaking, construction is relatively inexpensive in Wisconsin, at least for the sources of sand. All right. Now, this is a Florida beach. We're not going to talk about Florida beaches because these are sands that are made up mostly of shells. They disintegrate, they disappear, they dissolve, go away, and there's not much left when it's all done. But we will talk about sands that you can find along Lake Michigan. This happens to be Doctors Park, and you might be able to see even here in Doctors Park, there's some sands that come in. This is where the river or the stream is cut through. You begin to see some layering in here, some indications of past storms that came in and deposited sand. And we're gonna, so now at this point, I think, let me see my next one, we'll go back on. Oh, and before we go on to the Google Earth, I'm gonna say, if we look at the beaches along Lake Michigan in particular, this is one of the favorite things we do with students. You may have noticed this yourself. This happens to be at Grant Park, but you see it at Doctors Park and any natural beaches. You'll see this black material that fills along the lake. And what it is magnetite, the mineral magnetite. And it collects here. It comes out of the igneous rocks. It's part of most igneous rocks. There's a little bit of magnetic material. It's an iron oxide. And when it disintegrates and reforms into the sand, it just comes up. But because magnetite has a density of about 7.5, it's much heavier than sand grains, which have a density of about 2.5. So when the waves bring it in, the very first thing to settle out is the heavy minerals, which is the magnetite. They come in, they settle real quickly, and they settle down right along the shoreline here. All right, now, as it sits here, it is not magnetic. It's magnetizable, but it's not magnetic. You can, if you put a magnet next to it, as was the only thing he's doing here, we take these bar magnets, we call them cow magnets, we put those and we run them through the sand, and you pull it out. What you do is you pull out all the magnetite, because now it is magnetizable in a sense, in the context of in the presence of a magnetic field. So this you will see quite extensively on a lot of the beaches in Wisconsin, whether it's Lake Michigan or the small lakes, any place there's some of the glacial outwash stuff, you'll see it. If you go to some of the other Great Lakes, for instance, Lake Erie, you can still see some dark materials, but it's not magnetite. It turns out to be garnets. And that's because the source of the sands for Lake Erie are a little bit different than sources of sand for Lake Michigan. Lake Erie gets more of their sands from eastern Canada. We get ours more from northern Wisconsin, Minnesota, Michigan, coming across the Iron Ranges and the iron source in the north. So we get a very good gathering of magnetite. And it's, I can remember some years back that somebody was concerned that, oh, we got some pollution on the lakefront. Oh, no, not pollution, just magnetite. All right. Now, from here, we're going to start looking at some of the sands. And this is just a screenshot of where I'm going to go to. This is a Google Earth map. And I will pass on the link to Tim if anybody else wants to go and visit some of these sites on your own. It's a file, if you can get to this file, that provides access to different pieces of this Google Earth, okay? And it's, if you've got Google Earth on your computer, you can just open that file and it'll take you right there, all right? So that's one of them. So we're gonna be looking at the sands around here. We're gonna be looking at sands a little bit on the East Coast, up through New England and so on, a little bit down here. And then there's some important ones. Oh, actually, these are all some important ones through the central part of the state, which we'll also take a look at. And let's see what's in. And this is just the close-up of what we're going to see here in Wisconsin. And at this point, I'm going to be changing to the Google Earth, but these are the ones that, let's see if I can get out of this one and close. See if I close that one down and open this one. Okay, hopefully this will do it. Okay. Well, let me start with the one that we already know about, and this happens to be Atwater. Okay, and if I go to this one here, just some close-ups of and from Atwater Beach, just sort of see.
Well, I think we're still seeing the last slide on.
Oh, you are, okay. I'll see if I can get rid of that one then. Get rid of this one. Let me. How can I close this one out here? It's probably out here. Still there?
Yeah, still seeing the maybe. Oh, now you've got maybe a X on the top right that you could. I don't know if you want to close out or minimize it.
Okay, I'll try that one. All right.
So
Now
now we. Yeah, you might have
okay.
to.
Okay.
Reshare.
I'll try again. Okay, and let me go to this one. That should do it.
You might have to reshare your screen now because we're maybe.
You want me to do what?
You might have to reshare your screen.
Oh, okay. Cancel. Cancel. All right, where did I? Back here. All right. Okay, come back here. All right, and here we go. Hopefully.
Oh, yep. Something. This is, yeah, this looks
There
good.
we go. Okay,
Yep.
Very good.
All right.
Okay. So I was seeing it, but you weren't.
Exactly.
Okay, so this is Google Earth. And if we go to Atwater Beach, you can see some of the sands here. This is up, which you see if you walk down there. And then as you look at it in greater detail, higher resolution, you come down to the one that I did show you before, the grains of sand on Bradford Beach, at Atwater Beach, and you'll see what you can't see too much is the sort of the clear ones, but you do see a lot of dark ones. These are probably some magnetite here, some of the black stuff, and so on. But you'll also notice they're kind of polished, and that's what happens when you have sands that are washed around back and forth in beaches. They tend to get polished just as you use a rock tumbler. You get these things polished up, which again is quite angular. And the fact that they're angular tells us that they've not been in the environment for too long, because if the sand is around for a very long period of time, they bounce around, and they can have all the edges get round around. And so you get rounded sand grains rather than angular ones. Okay. So if we now go to, which is, sneak out here to another location up here. This was a place up near Utley, Wisconsin, which is a ghost town. But if you look at it, here we have, I'm just going to go to the finer sands. Let's see if I get down to this one down here. Oh, let's go down further. Okay. Look at this one here. These are all very rounded, very, very rounded. And I'm going to go to the companion picture. And you'll notice it's all about the same material. It's all quartz. There's no other materials in there, a few specks and so on. Let me go to the other one here, the coarse grained one. And you'll notice how this one looks. This is the same sands, but just a coarser version, meaning a coarser grain. You notice how rounded they are, and they're actually a little bit frosted. All right. This certainly is one of Wisconsin's great resources. This is the sand that was being shipped out of the state for what they call frac sand. This is the sand that they would sell off to petroleum industry to push down the wells to help break up the rock so they get more gas and oil out. And the situation is that because quartz is a very hard mineral, it doesn't break down, it doesn't compress easily. And the fact that it's all you got in these grains is quartz tells you that, all right, it's a very clean material, and it will do the job. Now, the fact that it's rounded, extremely rounded, tells us that these sands have been in the environment for a long period of time. The fact that they're frosted tells us that these grains were probably in a desert environment, or at least blowing sand dune kind of environment, where the tumbling of the sands one on top of the other actually brings about a frosted character to it. Now, these sands can be found all over the place. If we go to the actual location here, let's try here. Here's one of the places where they were getting the sand from. This is up in one of the sand producing areas, and it hardly looks like a sandstone, a hard stone, but up here, this rock, this sand in central Wisconsin, is loose enough that we're digging it up with a backhoe and sending it through big tubes to be sifted and so on. So that's one of them. This is Cambrian age sandstone. We can go to Wisconsin Dells. Let's go to this one here. You've done the duck ride. You see these great outcrops of sandstone there. And the characteristic that we see here, and again, you know, the sands are telling us something. And here we actually get a whole series of, certainly bedded, but it also is cross-bedded. And these are the kinds of characteristics that would tell somebody this was probably a desert environment. You get these sand dunes sitting around, producing slopes to them and all fine grain, but it's all one very uniform sand. There's no other minerals with it, right? We go to Wyalusing, right? This is an outcrop on your way up to Wyalusing. Again, a big outcrop of sandstone, and it's all the same thing. And what we know is that the central part of Wisconsin, I can go further north, we can come up here to Lake Superior. And guess what? You got sands up there too. Pictured rocks area, the towers there. It's all the same kind of sand. It's all Cambrian sandstone. And what it's telling us is that much of this part of the world back in Cambrian time was in fact a desert or near shallow ocean environment. And of course, at that time, Wisconsin was actually close to the equator. So we're looking at a very different type of environment than we have today. But the central part of Wisconsin, it's just filled with this Cambrian sandstone. You can, it's hard to miss it. If you want to take the interstate up through the middle part of the state, you'll begin to see these outcrops all over the place. All right. So that's several types of sand. The beach sand that we got from Atwater Beach, and we got the Cambrian sandstones from central part of the state. Now let's take a look up here in the Adirondacks. Sonnegan, not too dissimilar from what we saw at Atwater Beach or some of the other places. Again, very angular. The clearer kind of stuff is going to be quartz. This is also a glacial deposit type material. Glaciers came through, all the water flowing with the glaciers, pour it out, dump it out, and the lakes and so on. And it's just hasn't been in the environment very long, relatively speaking. It's been out. And so we get a lot of angular stuff, very similar to what we see in Wisconsin on the beaches. We can go to Cape Cod, and we saw those before. Same kind of thing, that the sands are very, very rounded, are not rounded, but very angular. A lot of different color materials telling us that the stuff hasn't broken down. Here's a little bit of mica sitting up here, right? And so it's just, again, it tells us something that this sand has been only in our surface environment, well, since it's glacial material, probably 10, 20,000 years maybe, okay? If we now go, we will look at one beach sand down here, all right? Down at Daytona Beach, all right? Very, very similar to a certain extent to what we saw in central Wisconsin, except here, the grains are not so rounded. There is some black stuff in here, which I'm not sure what it is. It could be magnetite, quite angular, but also not frosted. It's actually polished, all right? And so what's happened is that this is sort of the remains of sand that has worked its way all the way down the East Coast. The Longshore Transport of sediments along the East Coast, from the north to the south, it keeps moving along. And as that sand keeps moving along, it disintegrates, the clays come out, the finer stuff comes out. By the time you get to Florida on the coast, of the Atlantic coast, you end up with only material that is very resistant to weathering, and that is the quartz. And in this case, it's not quite like what we saw in the Dells or those places, It happens to be certainly more angular, but still it's dominantly quartz material. All right. So this material has probably been working its way down the East Coast for the last 10, 20,000 years as the longshore current takes along and just deposits along the shoreline. And we can, well, if there's any other ones over here that are worth looking at, but I guess that's about, well, I can give you one other one here. Let me get this one here. Oh, here we go. Now, if you get up to Lake Superior and just to the east of pictured rocks, you can go out to this place. It's referred to as the log slide, but these are all sand deposits from post-glacial periods. As the lake levels dropped, there was massive amounts of sand, and the sand got picked up and deposited in big sand dunes all over the area. And you've got about 200-300 feet of cliff face here that takes you down there, and the trip fun. The walk back up is not. But it's you can see this also. So with that, I think I don't think I've got any other material here unless I go back to the previous one. But there's some introduction into why sand is such a important part of our daily environment. It's as I mentioned before, it's certainly a major source for construction. It's an important part of your gardening, and it's a real resource. Not only that, but you can learn by simply looking at it. All right, and this happens to be Lion's Den, where you don't see sand, you see cobbles, because here the cliff face gets eroded away, the sand gets washed away, and only the heavy stuff gets left behind. And here you begin to see all of the rock material that is going to be breaking down all the good stuff that came out of northern Wisconsin, Canada, and so on. Okay, there it is, folks. What kind of questions we got?
So one of the first questions on the chat was, how did you get those amazing sand pictures?
Well, let me see if I can get out of this thing here. I guess if I close this, do I get down to